Good morning, everybody. Good morning, good afternoon, good evening. It depends on from where you are joining the program. Assalamu alaikum wa rahmatullah. Welcome to Big Bang Data Science Solutions Ramadan program, the Data Science for Good. We are in the second round of CRISP-DM and Business Understanding, which is probably the most important phase of your CRISP-DM if you were to use CRISP-DM for your project end to end. The more time you spend, the more effort you put into understanding the problem and framing the problem correctly, the better the end result, or the better the system you'll be designing. So it's time consuming. This part is time consuming. As I said, if you misunderstood the problem, most likely you'll be designing, probably something that was not expected from you or was not needed from you. So we are going to continue learning about this, business understanding concepts and steps and processes and phase. And next week, we are going to dive into data. So we are going to get the data, and of course, we are going to start some coding. So this is a data for a real scenario, and we will be using this data. And of course, we will start, the process of understanding the data, understanding the attributes, understanding the shape, the disposition, the position, the structure of your data. Then, of course, using Python, and after that, we are going to move into the process of cleaning, now transforming the categorical to date to date, transforming categorical to numeric, transforming categorical to numeric, and also dealing with some problems. We'll be dealing with some problems. And I might end up using different data, but this is the data that we use for this specific problem, the problem with our insurance. So we are going to have a lot of fun next weekend. Hopefully, if you guys want to join again, so we are going to have definitely a lot of fun with the data. Of course, we are going to learn. Those who are asking questions in the chat, please go ahead and raise your hand and simply speak up your question, because I don't think I have someone here to monitor the chat. So, what is about the Python libraries which are written in your curriculum? Oh, you're talking about the curriculum. This one. Yeah. Okay. Yeah. So I thought Ed covered this. So yeah, let's yeah, we are going to cover these libraries. I'm going to go through them next weekend. So before we go to data, we will cover the six most common packages: NumPy, Pandas, Matplotlib, Seaborn, and scikit-learn. It's simply a short crash course on all these libraries. Okay. So that is the plan. Now let's dive into the lecture one more time. So yesterday we learned about dealing with the problem for the first time. So you've been hired as data scientist to fix some business problems. So you will be given either as a team or either as a data scientist a problem statement, and of course your job as data scientist, your job as data analyst, is to extract a bank of questions out of your business statement. And it could be descriptive questions, predictive questions, diagnostic questions, prescriptive questions. And they have to be interesting questions, some challenging questions that probably you were not able to find answer through other methods, like using SQL through your database. So yes, and these questions or this bank of questions that you'll be that you need to design You have to include all the team members because they have more knowledge, more experience, more expertise in terms of understanding business better than you, and in terms of understanding data better than you. Okay, we always start with with framing a problem, and that is what Albert Einstein said. If I was given 1 hour to save the planet, I would spend 59 minutes in simply framing the problem, transforming the problem into analytical and quantifiable problem, extracting interesting questions with the help of my team members, and we start from there. Okay, and we talked about how you determine the micro methodology or the method or the process, and the micro methodology for your project. That is very important to determine which micro you are going to use. And of course, in the micro, there is a lot of statistical techniques, machine learning techniques that you need to learn, you need to use to design the solution. It totally depends on your objectives. If your objective is simply exploring in a historical data, trying to find what happened a few years ago, or a few days ago, or a few hours ago, you could simply use some basic statistics. You really don't need to use any machine learning. If you were to build a prediction model, you are going to need the data, and in the data you are going to need a target variable. So we have a couple of modeling or machine learning type that you could apply. Clustering for unsupervised learning, regression for supervised learning, classification for supervised learning, time series for finance, data science, factor analysis for figuring out the important features or for dimensionality reduction, general linear modeling for regression, graph. This is used for graph-based method is used to find the optimal distance between 2 point A and B. And if you were to use, if you don't have a data, sometimes you might be working on a project that there is no data. You simply want to figure out the optimal. You need to simulate the data, and we have a lot of methodologies, a lot of algorithms and modeling that you could use to design a solution that does not require a data. Okay, we talked about the blocks. I'm going to simply highlight and skip. The data block. It has to be in a certain assumption. We talked about building blocks. Building a model using any of this list. So this is all the list of the models. So we already know the models we are going to use, and we know what we're trying to do using the methodology. And now we need to discover. We need to find the parameters, the hidden patterns, the hidden relationship within your data, and this is what we are going to use to determine, to predict or to make an inference for unknown, unseen, and new data. Okay, we talked about the team, and we mentioned that in your team you need to have people with at least 4 expertise, data expertise, business expertise, and development expertise if you were to deploy the model into production. And of course, we are going to need you as either a technical data scientist or a citizen data scientist, kind of a person who is managing what we call application support of the model being implemented into production. Okay, and yes, this is another typical team. The main experts and and business expert will definitely do some research lead, so to help you to find assumptions, now gather requirement, drive questions, the predictive questions that we talked about, or descriptive questions, diagnostic and prescriptive questions, and they know the business. And of course, we are going to deal with data, so we are going to need an expert in the field who can explain data, explain the data, where the data is being stored, how to get access to the data, which table is which table we need, if there isn't any discrepancies, any typos, any errors in the data, we could have an answer right away. Okay, and also provide us a data dictionary, which is simply a metadata on your data that you are going to use, and that's metadata can be used to extract, drive questions. And of course, we are going to need you as data scientist, now someone with Python skills and machine learning, data science, analytics skills in general. And of course, we are going to need the boss. We are going to need someone who can manage the team. Just simply make sure that we have access to the data, the time that we want, and the time that we want. He can answer any questions. He can facilitate the conversations and the interviewing of the other departments, members, and managements, and of course enforce the learning once if we are working on a project and we got a solution for a specific problem. Of course, that solution has to be implemented, either has to be enforced or has to be implemented, or the result needs to be distributed. I really don't care about that. Someone has to do that for me as a data scientist. So the manager will facilitate that type of things for you and make your life much, much easier than working on a project on your own. And as I mentioned, I worked on a project on my own and I ended up losing my job. Simply, I underestimated the amount of time needed to complete the project. I thought I can do it within a few hours. End up wasting almost three weeks simply trying to understand the data. Okay, that is very important. And so we learned also as he state, this is what the business is struggling with. And of course, the business wants to be in a better state, and a state where they are not losing clients, in a state where they don't have any fraudulent cases, in a state where the business is up and running without any problems. That's an ideal, state, but that is what the business is desired to go through by simply investing and bringing you in as a data scientist. And so we understand the problem as it state. We understand the objectives. We understand how to measure them, how to measure the transition using some business KPI or business measurement. And as data scientists, so this is where you really need to think about applying some new data science skills. So from as a state all the way to success, we are going to need you there, but the heavy load is on your data expert, domain expert, and business expert. After we identified the business measurement, now it's time to narrow down the scope of the project by determining the optimal entity or unit of analysis. And of course, if we are doing prediction, we need to determine what is exactly the part of the data that we are trying to predict or trying to analyze or trying to find a solution for. And of course, as a data scientist, once we need to evaluate our solution using, of course, some measurements, some matrices. Depends on the type of the project, type of learning that you use for your project. Okay, and yeah, so this is an example of simply related to the insurance case. So as it state is we are losing money. That is the challenge that the business is having to deal with for a very long time. Even though they have a 30%, even though they have an investigating team that investigates up to 30% of our claims, you know, to be stayed, we want to be use a machine learning based model that determine that filter out all this systematically, automatically filter out all claims. And the success is this is a measurement provided by the business, and this is simply an example. They want to reduce the fraud, the money lost because of fraud by 50% for the first 6 months and 100% for the second 6 months. Then, okay, the entity, this is something that we determine as data scientists with the help of the main experts, is what is the one things that we want to analyze. And in our case is the claims in general, rather than as I said, we could analyze other things, like we could analyze the payment, we could analyze clients themselves, clients behavior, to see if there is any strange behavior for specific type of clients bearing different criterion. And we could analyze the policies to see if there is anything strange within policies that cause that has caused fraudulent loss, money loss because of fraudulent, or would cause any money loss because of fraudulent. And finally, the target, and is going to be our fraud is yes or no. And if your data does not have a fraud, okay. And now, so I was talking about so in your data, if you don't have a target variable, sometimes you might need to conduct an external audit on all your 6 million claims and determine which one were correctly approved and incorrectly approved, and simply label them by creating an extra column within your data with the label of either F for fraudulent, L for legitimate, or a 0, 1, or minus 1, 1. Just, classify your 6 million records as either they were correctly approved or incorrectly approved. And that is the target variable we want to understand better by applying some machine learning or statistical analysis to your data. Okay, and finally, we are going to use a confusion matrix, which is a table that compares the actual target variable with the predicted target variable. And we want to design a solution that provides predicted target variable as closer as possible to the actual target variable. So that is the plan. As I said, we might not end up using the R insurance data. So we probably might use the churning data, and the R insurance is related to different project. Okay, so and this is where we stopped yesterday. Yesterday we talked about business understanding, and in business understanding, we talked about the objectives first. We talked about the objectives. What are the objectives? Where the management are heading to. Well, after, of course, understanding the challenge that they are facing, what is the to be stated. So we need to identify all the objectives. It could be one objective. It could be many objectives, but identify them first. Then try to extract features, try to extract questions, interesting questions from your business statement, combining the business statement, the data dictionary, the objectives. You could definitely come up with many questions, interesting questions that would help you to drive smooth from the beginning of the project all the way to design a solution to be implemented. And of course, we need to know some measurement. This is the business measurement. How would you measure the success of a project once you are done? And if you know that you will be doing predictive analytics, you are going to identify the target variable. And in our case, for the auto insurance, there might not be any target variable in there, so we might need to hire a third party to do some external auditing all the previous cases, and as I said, determine if they were correctly approved or incorrectly approved, and label the historical data, the claims in the historical data accordingly. So at the end of the audit, we should have one extra column to label any every each and every claims in the historical data as either it was approved correctly or it was approved incorrectly, and you could choose any method to label them. You could label them as correctly, incorrectly. You could label them as legitimate, fraudulent. You could label them as 0, 1. You could label them as -1 and 1. Whatever method you decide. At least now you have a target variable. And you need to identify the analytical approach based on the objectives, based on the questions that you are trying to that you extracted, and based on if you have a target variable or not. You could simply easily determine the direction. It could be simply discovery and exploration, as by or what we call descriptive analytics. It could be a predictive analytics. It could be a combination of descriptive analytics and predictive analytics. It could be going through diagnostic analytics or prescriptive analytics. There are a lot of, there are four descriptive analytics, four analytic approach, and you have to determine the optimal approach by simply filtering out your business objectives combined with the questions that you extracted from your business statement, and taking into the consideration the data dictionary provided by the business. And so if you know that you are going to be deploying the model into production, you really need to prepare for it from the early beginning. Otherwise, the transition is going to be so tough, so challenging. Okay, and if you have a project manager, then we have a start date, end date. We know what we are doing. We have a date. We know where to stop, and of course, we cannot promise anything in between because we don't know our data yet. We don't know what to expect from data. Data could be corrupted. It could be data could not probably take you anywhere, even though you are going to spend 5 months, 6 months, and you end up finding that this is a totally wrong direction, totally wrong data. Or you could be in the right direction, but the data has nothing to tell, has nothing to tell about the problem the business is struggling with. So we cannot promise. Yeah, we are gonna, of course, we are gonna promise we are gonna finish the project on a time, within the budget, but the outcome we cannot promise it. And it is very important to identify the team. I mean, identify your team, which we talked about, and also identify stakeholders. That is very important. Yeah, this is the book. This is the book that I recommend, and of course, it has a nice chart. It has a nice chart in there. It's called stakeholder cheat sheet. It's a nice chart that will help you determine how to deal with the stakeholders end to end. So this is a very good book. I recommend you guys going through this. But let me see if I can find. Okay, look into this. They say here, the author says here, if you cannot answer most of these questions with a yes, your project might be in trouble from the beginning. So if you cannot answer these questions with a yes, you are having a problem from the early beginning. That is how important, bring understanding, building the relationship with stakeholders is from the early beginning. Otherwise, you might end up wasting my time, my energy, my effort, and of course, I'm gonna fire you. I'm gonna fire you right away. So, this building a stronger relationship with stakeholders is a game changer. And finally, as a team, we are gonna work on designing the ABT, assuming that we are doing this for the first time. Otherwise, the data is already there. In most cases, the business will give you the data. But at least assume that you've been hired as data scientists to work for a company that they just established the analytics, the analytical team. They don't have any experience. You are the first person probably to conduct a project for them. That is the worst case scenario. And these approaches here, phases, steps, processes, they are built, for the worst case scenario. The best case scenario, you have the data. You really don't have to go through this. So, any question about business understanding? Please speak up. Yeah, Salim, he said, how do we differentiate the role of data scientist and data expert, data engineer? Data scientist is someone who takes a data to solve the business problem by applying some scientific method. Data expert is someone who knows the data. It could be a data engineer, it could be a DBA, it could be someone with a lot of SQL experience who can simply pull out the data anytime from any servers, from any databases. That is in nutshell the difference between data scientist and data engineer. Data engineer, they know SQL, they know database in general. Data scientists, they know R and Python, they know some scientific method, they know some machine learning to transform the data into a product. Okay, other questions, concerns, please.
Hey Mo, this is Amir.
Yes, Amir.
So, uh, business understanding. I know different clients have different requirements, but let's say if you're going to this insurance company, what's the time like? Will it take to go through all business understanding? Like, what's the estimated time? Let's say if you're working for an insurance company to go through each step.
At least between 60 to 80 to say to I would say 60 to 70% of your entire project.
Oh, okay, okay,
Yeah, both of them, actually, both of them, all the business understanding plus data understanding, and no, all of these three, they are probably 80%. So
okay. So, what's a typical like? Is it a 6 months project or 1 year project?
most of the project that I worked, most I'm not, you might don't copy me wrong. Most of the project that I worked on in the past, they are between 6 to 8 months.
Okay, okay. Thank you.
Yeah, but because of course you are going to get 2 months project, 1 month project. You could have 1 day project. Hey, find me what's going on with this data. Boom, I could use any application like let's say Tableau. You got a data. All what they want is finding what is the most profitable states out of in the data. It's simply one click. Yeah, there is.
Okay.
Yeah, it depends on the business need, but typically the project is 5 probably to 10 months.
So if you have to start from scratch, it has to be like 5 to 8 months if you're starting from the
It
scratch.
depends on how heavy the project.
Oh, that's true. Yeah. Okay.
No,
Okay.
if the management they already have one question they need an answer, there is no implementation, there is no modeling, there is systematic or automation. It's going to take you probably a couple of minutes or a couple of hours.
Okay. Okay.
Okay, like if I were to ask you a question, for example, hey Amir, get the data, find out who had the policy report in the past. Very
Yeah,
simple.
more,
Oh, that.
Yeah, very simple
well,
question. And of course,
Furkan,
you are not
Furkan,
going to take 5 months
question.
to do this. Yeah, please hold on. Yeah, you cannot take 5 months to do that. It's simply one click. But if you were to design a system that would determine if Amir to call, if Amir calls us today with an incident, if we were to determine if Amir's incident is fraudulent or legitimate, of course we have to go through. It's going to take a time.
Okay, makes sense. Makes sense. Thank you.
Yeah.
Thank you very much.
Other question, please.
Yeah, more, so Mohammed here. So my question is the quantity of the data, like number of records, important? So that's part one. Part two, which is related to the same thing with the data, is how do we make sure that we get all the data? And as we move forward, we assess, then we will find out, or is there another way that you suggest that the data that we receive is complete, or there are some missing parts to it? So that's part number two. And the part number three of the question is, what sort of sign up, or I should say the sign off, has been required when we finish off the data analysis before we begin the
Yeah.
modeling process?
Muhammad, let's take one at a time, please. I cannot.
Sure, sure, sure,
I have
sure.
a short memory. I cannot remember all your questions. So let's take the first one. How much data you need. So the more data you have, once you are going to move into data, the better learning you are going to get. If you have, for the insurance, if you have 10 cases, of course you are not going to learn the pattern. If you have 50 million cases, you are going to learn a good pattern. So the pattern will be probably more accurate with more cases than the pattern with few cases. So the more data that you have, the better. So, but sometimes, when you have a huge data set, a big data set that you can handle, and let's say that you have, let's assume that you have 6 million records. Okay, this is all your data. And of course, it happened to me in the past in one of the projects. 600,000, only 600,000 medical record. It crashes my system. So when you have a huge data set, we are going to do some sampling.
Okay.
We are going to
Okay.
do some sampling, and when we are talking about sampling, there are, we need to do some sampling. And when we are talking about sampling, there are a lot of statistical sampling that you could apply. So I'm going to name few. Yeah, I'm going to name few. And of course, we are going to talk about this with much more detail once we go into data. Okay. So we have to do sampling. For two reasons. When do we need to do a sampling? Yeah, we have to do a sampling for two reasons. Number one, when the population is very hard to obtain, when the population cannot be obtained, no way to do a population. I'll give you an example. If you are working on a project and you determine the impact of cigarettes, so you are gonna need a data for all smokers across the planet. So you need to go through every person who smokes across the planet to get that data, and that is totally impossible. All right.
Yep.
Number two, when your system has a limit memory, RAM, or let's say no capacity. And this happened to me, only I had to deal with 600 records, and it kept crashing my system. So now we are going to do sampling. Sampling, there are two types of sampling: probabilistic, probability sampling, and non-probability sampling. One we are going to use a probability, one we simply we are not going to use a probability, and this is very dangerous. Now, the non-probability is very dangerous because when we are doing sampling, we want to make sure that the samples here we are going to use do represent a certain accuracy. They represent the population. If you drop a sample out of your population and the sample does not represent the population, you are going to create a biased system. So we want to make sure that the sampling we are taking out of these records, out of the population, do represent the population. So the first method is called the simple random sampling. It's simply we are going to take, let's say we are going to take 10%. So we are going to take 10%. We are going to build a model 1, and model 1 has accuracy 1. Then we are going to take another 10%. We are going to build a model 2 and accuracy 2. Then let's take another 10%, and we are going to build model 3 and accuracy 3, etc. And at the end, we are going to do an average. Okay, that is simple random sampling by simply putting out a percentage randomly. And let's assume this is you. I mean, we have your records in there. So that record, since we are doing random, you could be in all these samplings. It could be all this 10%, and probably it could not be in any of this sampling. That is a sampling with replacement. I'm sorry, that is a simple random sampling. The second type of sampling is called stratified. Stratified sampling. Stratified sampling is we are gonna split this data here. We are going to split this data here into equal chunk of data. So let's say that we are going to split into 5. So this is 1, 2, 3, 4, and 5. So 1, 2, 3, 4, and 5. That is called stratified. We are going to split into equal size. So we are going to have the same amount of data on each chunk, called chunk of data. And we are going to build here model 1. We are going to build 5 models. Model 1 with accuracy 1, model 2 with accuracy 2, model 3 with accuracy 3 if we are doing classification. And of course, if you are doing regression, there is a different measurement. Model 4 and model 5, and we are going to do averaging again. Average. That is called stratified sampling. Clear? So far, so good, everybody?
Yep.
Any doubt, any concerns, please? Please speak up before we move on to other different sampling.
So when you say accuracy 1, 2, 3, so they're all the same amount of accuracy, or they're all different accuracy?
So every sample has every sample will have different records, different records. Of course, when you build a model, you are going to have a different accuracy.
So this
Okay.
SRS, you showed like 10%, 10%, 10%. Should be like, if you calculate, should be 100% at the end.
I mean, you are not going to do 10 times, You could do one time or two times. If you want to do 10 times, that'll be good.
Okay.
If you do 10 times, at least, mathematically, one third or 36% of your data will never be used, will never be touched. Okay, out of this sampling, one third probably or 36% might not be used. So
Furthermore,
yes,
what's the difference between the first and the second? In the first one, is it only 10%? Are you only accounting for 30%?
yeah, you could do 40%. You could do any percentage. I'm just trying to give you an example of the random sampling.
Okay, got it. And why is a compute RAM or capacity should be a restriction, right?
I mean,
Because
yeah, if you are running on a server, this is not a restriction. But in my laptop, I have a small, an old laptop with a capacity, and of course, when I use the 600,000 records, it simply breaks my memory. It simply shut down my system. So I had to go through the sampling. Unless you have a superhero computer, you don't have to do a sampling. But again,
so
even though with the superhero computer, I think if you have a huge amount of data, you might need to do sampling because the computation it takes a lot of time, and especially if you need a speedy answer, if you need a fast answer,
uh,
that is
so
yeah.
uh, are we saying that the accuracy of the sampling would be the same regardless of
No,
you use a
so
larger set?
yeah, I mean, just let's stay away from these terminologies at this point of time. This is something we are going to learn in the future, but the accuracy is not going to be the same. Every
Okay, thank you.
Yeah, 10% here is different than this one, is different than this one. Of course, if you have a different data, you build the same model, you are going to have a different result, and the accuracy is the result. So we are going to talk about this since someone asked about the sampling. That's why now we decide to talk about this at this point of time. But this is a future topic we are going to learn later. And another sample is called clustering sample. Clustering sample is simply build a cluster, and the cluster is a machine learning. Cluster analysis is machine learning, which it could be k-means clustering or hierarchical clustering. We are going to use in this data here to find some hidden similarities between the records, and we are going to classify. We are going to cluster them. We are going to segment them and group them based on those similarities. So you are going to see a few animals, classified like clustered like this. It depends on similarities and dissimilarities. This should be probably a time consuming because you have to know some machine learning before you apply clustering analysis. Also in machine learning, there is so this is not the simple random sampling and stratified sampling don't require any machine learning, and the clustering requires some machine learning. And there is another one is called random sampling with replacement. And random sampling with replacement is simply it's so this is a random sampling with replacement. So let's assume we are going to take no, this is a part in here by random. So we are going to take this part here by random. Okay, we are going to take that part by random. It's random, and we are going to build the first model 1, and of course we calculate the accuracy. We got accuracy 1, and we are not then we are going to keep no then we are simply going to keep the sample that we took and the population. We are not going to do anything. No, we are not going to remove it. Okay, then we are going to take another 20%, 30% sample random. We are going to build a model number 2, which then we are going to calculate accuracy of it, and we are going to put it back. So we are going to use a random sample with replacement. Means take a percentage. So a random sample with replacement is simply a parameter you pass to the model. You tell it sampling equal true probably or equal false. That simply knows if it should use random sampling with replacement or without a replacement. Okay, the without a replacement is totally the opposite. The without replacement is the opposite. So, and here finally we got random sampling without a replacement. So we are going to take this animal here. We are going to build model 1, and we of course it will have its different accuracy. Okay, so now we got 6 million in the population. When we first pulled the first percentage, now we got 6 million minus this, let's say 10%. Okay, now we are going to take another 10%. It is going to be somewhere here, and we are going to build a model number 2, accuracy number 2. And what do we have in the data? What do we have now? Can anyone tell me?
90%.
We are going to have 6 million
minus 20%.
minus 10% minus 10%. Okay, and let's do a third one, a fourth one, all the way until we have a 0% left in the data. That is a random sampling with a replacement. So which one to choose for your model? It's really hard to say, hard to tell unless we understand the scenario, unless you understand the problem and the data. But if I were you, just to be on the safe side, I could try different sampling. At the end of the day, we want to grab a sample that represents close to 100%, at least represents to a certain level the population. If you grab a biased sample, of course your end result will be biased. The end result will be biased. So that is sampling.
Question.
Yeah. Please hold on. Yeah, that is how you deal with in a huge amount of data using sampling. As I said, there are two types of sampling: probabilistic or probability sampling and non-probability sampling. Probability sampling is simple random sampling, stratified, clustering, random sampling with a replacement, random sampling without a replacement. Yes, Amir, what is your question, sir?
So you, like in the last one, you said without replacement, right? You said it goes all the way to 0%. I remember in the beginning you said that out of the whole data, we use 80% to train the data, and then use 20% for actually check how
Right.
if it's really good or not. So I mean, is it like when you're doing sampling, it's not like you are training? Is it something?
No.
I mean, okay.
So let's say that you took 10%. Okay, and we are going to split that 10% into 80% and 20%. So we build a model on 80% of this 10%, and we train the model on the 20% of this percent to see how good the model performs in this. And we are going to do all of this sampling.
Okay, so you're doing both. Okay,
Yeah,
got it.
Yeah, please hold on. Let's make sure the brother asked question is clear with this.
I got it. Okay, so you are doing both like training and then testing in this sampling. Okay, got it.
Yes.
Okay. Thank you.
Yeah, welcome. Other questions, please?
Yes, I was gonna ask, I mean, as you have multiple model flow, like M1, M2.
Yeah, Amir Alam, can you please speak a little bit louder because I barely hear you, sir.
Yeah, I was gonna ask, like, if you have that kind of breakdown of M1, M2, M3. How do you efficiently model multiple of these models in real life? It's because each one may take some time. Is there any automation process that
I mean, as data scientist, I don't. Yeah, you could automate through scripting, but
uh
your responsibility as a data scientist is to find the optimal model, the best model with the best parameters for a specific problem. So you have to go through try in as many models as possible. So
Okay,
yeah, it's a time consuming, but at the end of the day, you will have 100, an accuracy, an accurate model.
correct. Okay, sounds
That
good.
you
Thank
have
you.
to test and test and test. Try this, didn't work. Try the other one, didn't work. How about this? How about that direction? How about if we add more data? How about if we decide, if we go through a different what we call it, different sampling, etc. I'm going to share with you.
Yes.
So, this is something that we learn in class. So, at the end of the day, when you have a model that you build and it's not up to your expectation, so how do you handle it? So, you could handle it at the data level, at the model level, analytic approach level, parameters level, matrices level, and target variable level. If you if you're doing prediction. So there's a lot of directions, at the data level, check your sampling. Maybe you did something stupid about the sampling. Maybe the sampling does not represent the population. Go ahead and you tried stratified sampling. Let's try random sampling. Let's try this type of sampling. You did a partitioning 80 at 20. Let's do a 70 at 30, 75 25. Learning method, you did supervised learning. Let's try, probably we should have tried unsupervised learning because we have a wrong target variable. Then at the mod level, you did a regression analysis. I think you should have done a time series. Okay, and analytical approach, you are doing descriptive analytics. I think we should do predictive analytics. Parameters level, we build a model with a default. I think we should now use random search or grid search to find the optimal parameters. Matrices, we use accuracy. I think because the target variable is not balanced, I think we should use precision or recall. Or maybe the target variable is skewed, is not normally distributed, or is imbalanced. So this is some of the. You can take a screenshot. You are allowed to do that. And this is something I designed for my 30 weeks program. This is a roadmap of what need to check prior sharing the model with the management. So you have to try and keep trying until you find the optimal solution for the problem you are working for. Yeah, there is no one straight answer. I really wish there is one straight answer. And by the
So
way,
Mo,
yes.
so how would you know that you are getting there? Does it come with the experience, or you would know that, okay, I need to go and change my course, I need to go and change my strategy?
I mean, the number one is it comes with experience. Yes, but so for example, if you were to build a system for your management to determine fraudulent, and at the end of the day, you put the system in production. You put your system, machine learning system. This is production. This is in cloud. You calls in. Yeah. So this is me taking information, and this is you calling with an incident. Okay. So when you call in with the information, they go through. Actually, you call me with the information. The information will go through machine learning, and we have here a decision to take. Okay, let's say that this is how you determine live if your system that you designed is professional or is doing what's supposed to do. Let's say you call, let's say we have 5 people here, they call today. All of them, they have accidents in different states, in different locations, different timing, different cars, etc. So you got you recorded all these incidents. You push the incidents, the information to your machine learning, and your machine learning says no, 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 means they are legitimate, and you approve them. And next day you did an audit and actually find them one. They are fraudulent, all of them. So of course, it's very early. Before you distributed the funds on all these cases. Luckily, you did some auditing, and you find out the opposite. So this is how you learn that the model that you design, and this is probably still late. Once you deploy into production, that the model is deficient, is not acting correctly. So you might have done something stupid somewhere in your somewhere in your entire project. So it could be about sampling, it could be about data, it could be about the partitioning you did, it could be about the method, analytical method, it could be about the modeling, it could be about the accuracy, and this is how you learn. So you learn by making errors, by breaking the systems. Okay.
More quick question.
Please, hold on. Furkan, please hold on, brother. Let me make sure that the brother asked question is clear about his answer before we move on.
Yeah, I'm clear. Thanks, Mo. But I think knowing there are so many techniques, so many
Yes, it's a journey. It's a
ways.
journey. There is.
How do you know, as a new data scientist, that you are picking the right approach?
Trust me.
That was my question.
I was there a few years ago. It's a journey. There is no program on the face of the planet that would make you a superhero data scientist.
Okay, thank you.
Comes with the practice. Read articles, do some Kaggle, competition. Read, go through, online training. So it's a journey, and the more effort you put into this, the more knowledgeable you're going to become. When I first started, my first,
This is one of my friend actually. He's in our community, that website which you were talking about.
Yes, brother. Yes, here. But talk to him. He may be the one who organized the presentation, but that was back in December.
Yeah,
and I
I know them very well. Yeah,
I learned from it. So if you are new to the field, please don't panic. Just put some effort. Complete the program, go through the slides, keep learning, and I promise you, within 6 months from now, without going to school, without paying anyone anything to learn data science, you will be a data scientist. Data science is to learn if you have the passion, patience, commitment, and you have a heart. You have a heart for data science. You are going to make it, regardless of your background. Okay?
Okay, so I understand that you explain the basic concept or the techniques, statistical techniques, and I appreciate it because everyone is not on the same page. So that will be helpful. The question is on that. Basically, you mentioned the clustering sampling, right? Which is this the only sampling which is using machine learning, or is there anything else?
Of course, yeah. I mean, the random sampling. This is machine learning, and this is machine learning. Yes.
Oh, those last three? Okay.
Last three, they are machine learning. I don't know if there is statistic. I mean, I think you could do statistically without machine learning. I don't know about that, to be honest with you, but I know I use them with machine learning. It could be without machine learning. I really don't know.
Okay, fair enough. Yeah, that's fine. Mm-hmm.
Okay, let's move on. Now we are done with business understanding. We are good to go. Everybody is happy. We got an ABT. We got a team. We got a good relationship with stakeholders. We got the object identified. We got the feasibility identified. We got the framing. we got an identifying the measurement, we got the target variable, we got everything ready to go. Everything ready to go, and with the help of business expert, domain expert. So now, as a team, we are going to take that ABT and we are going to transform it into features.
I have a quick question. So,
Yeah.
what is the ABT, the analytics-based table?
Is ABT, if you were here yesterday, we talked about it, is the pseudocode of what you need as data, as far as data is concerned. What do you think? What do you need from the data? Okay, it's not the data. Just tell me what you need. So you could tell them, since we are doing claims, we are going to need all the information from the claim side, and probably we are going to need demographics of the clients. We are going to need some finance information. What was the last time they paid? How much they paid, etc. And we are going to need some information about their policies. That's all what you need from the conceptual standpoint.
Right.
And that concept now will be transformed into reality. Now we need age, we need marital status, we need time of accident, we need this and this and this. So we are going to transform the IBT into features. And now we are transitioning technically from business understanding to data understanding. So we are going to get the data. We are going to collect the data. As I said, if you are lucky, the data will be given to you. Someone must mute her or himself, please. So please mute yourself. There is a lot of background noise coming from someone's end.
Brother Mo, I have one question, please.
Yes.
So the data scientist is the one to create the ABT table, right?
No, it's a team.
Oh, okay.
It's you and the team. Yes, you are part of the game. But you could do it, but I'm talking about the best practice. You could be the person who creates the IBT, but the best practice, it's you and your team.
Right, but usually, like there is a person or a department that owns it, right?
Yeah, no, the project owner. No, they own the project. No, they don't know what is ABT. There is your terminology. So when you design your team, make sure that in your team you have the people with for expertise, and those expertise is what you are going to need to extract, to design a complete ABT.
Thank you.
Okay,
Brother Mo?
Yes.
Who will identify the target variable? It is data science or some other person?
It's the team.
Means it is the audit team? Like it is some company will do some third-party audit? Or?
I mean, yeah. So the target variable, if you know that as a data scientist, you know that you are going to be doing prediction. So you know that the management wants to predict if a case or if a claim is going to be fraudulent or legitimate. And you joined the team with some experience, and definitely you look, you ask them, can we identify, simple question, is there a way we can do we have the ability to identify claims that happened that already been approved in the past, and find out if any of them were any one of them was incorrectly approved. If they say yes, we have that, then you don't have an auditing. We already have something in there. If he say no, he said no, we need to audit all the claims, and that is how we can learn. If you don't have a target variable, you cannot predict the future. Okay.
So they have to perform the audit before to start this all stuff.
If they don't have, it's not, you could do auditing, you could do different ways to extract your target variable. But auditing actually is the best terminology that the best approach that you could use to determine if the previous cases were correctly or incorrectly approved.
Mm-hmm.
Okay.
Thank you.
You're welcome. So now we have
any
Yes.
Sorry, any book or any material related to how to identify this target value for different, just for as experience for different companies, just as example.
Honestly, yeah, I really don't have a book in mind, but there is one. You should start your journey learning any programming languages, R or Python. So don't focus on one area and forget the other. Knowing Python is not going to make you a data scientist. It is a requirement, but it's not going to make you a data scientist unless you know how, where, when, what to use it for. Knowing R is the same. You have to learn the whole package. Anyway, so once we transform the ABT into features, now you are telling the business that we need demographics. Under demographics, we are going to need age, marital status, let's say gender, income, and this and that. Then now it's time to collect the data for these features. And collecting the data is a nightmare unless unless the data was given to you, or unless you are working with a superhero domain data expert, a person who knows where the data has been collected or has been stored, how the data has been collected. It's going to be a nightmare. Okay, I had one of the reasons why I failed in a project that I lost my job in one of the projects is simply number one, the data was given to me was corrupted. I looked into the data. It has columns and rows. It looks very well organized. It looks like the right data. And I did not start with business understanding. I jumped straight to trying to analyze data. And I looked into data. I know what they want. And they said, okay, I'm going to give you something towards the end of the day. And it took me almost 3 weeks to figure out. Okay, so then once you have a data, and the data could be, by the way, data could be from different data could be different resources, different format, and this is you. Data could come in a different shape, different format, different structures, and from different resources. So you could need something from this animal here. You could need something from Twitter. You could need something from this animal here. So how do you combine them somewhere? And so now you end up having at the end a tabular format, something that looks like this. And that is where you can apply any scientific, non-scientific methods, statistical analysis, machine learning, etc. So the data is not always in the format, in the shape, in the in the format, in the shape that you are familiar with. Okay. Okay. So once we transform ABT into features, we are going to collect the data. Then we are going to, of course, let's say that we are going to use R or Python. Now, some R's and Pythons, we need to install some packages. And in our case, we need to install the pandas, NumPy, matplotlib, some part of the scikit-learn. And that is probably a topic we are going to go through next week. Yeah, I'm going to, Ed, are you here? Ed.
I'm here. I was just muted.
Yeah, can we do a session next week on the most common libraries for Python?
What are you looking at? 2 hours outside of Saturday and Sunday? No problem.
It has to be within the. It's going to be on Saturday. It's going to be the in the program, not outside the program.
Oh, so Saturday, 12 to noon to 2 Eastern, right?
Yes.
Yep, no problem. We'll do the 3 classic libraries that you absolutely have to know. If you
I really thought we covered them because I was not in the class.
Not this class.
Okay. Yeah. So yes.
This is your 3rd session, right? I think.
Yeah. Anyway, so we are gonna do we are gonna train you guys on how to import packages, especially the most common, the most classical packages used in Python. So
Yeah, we're playing Saturday. I don't know. It's probably the last day in April. 12 noon to 2 p.m. Eastern. No
yes,
problem.
yes.
Got it.
Thank you, sir. Thank you. So
Brother Mo,
you're welcome.
Brother Mo, one quick question. The slide deck that you are currently going through, is that in week 2, or are you going to share separately?
Yeah, I mean, I'm gonna put it in the week 2.
Okay, thank you.
You're welcome. So we are gonna import packages after, of course, we learn a little bit about them, and we are gonna read our data. We are gonna read the data that I shared with you, and now we need to spend time understanding the data by simply applying ADA, stands for Explorative Data Analysis. It's really easy to use. It's simply functions. Without no prior knowledge, you should run them easily. There is no coding. Sometimes you might need to create your own codes, to the specific things for you. But the packages we are going to use, that they will do most of the jobs for us. So we are going to apply some ADA, exploratory data analysis. And of course, why do we need to do ADA? To help us understand the value, the quality of the data. As I said, the quality of data drives the quality of the solution you are going to be building. If you have a garbage data, I promise you, you are going to end up having, approving claims that were not supposed to be approved, or denying claims that were supposed to be approved. So that is very important. Now we are going to spend a lot of time, probably the same amount of time that we spent in business understanding and data understanding. So we are going to apply some exploratory data analysis. We are going to apply a lot of data visualization. We are going to build bar plots for categorical data, histograms for continuous data, a scatter plot to find the magnitude and the direction of the relationship between two independent variables, box plot for 5-number summary of your data, and line plot for time series, heat map for correlation analysis, etc. There's a lot of visualization that we could use, and there is one of the website I'm going to share with you. So go through this, please. I'm going to share in the chat. So this is the most common histogram, plots that you could use, depends on your problem. But the most common ones is bar plot for categorical data, and what else? Bar plot for categorical data, histogram for continuous data, and violin plot, and word cloud for text data, and there are all also scatter plot. It should be somewhere here. Scatter plot for relationship, heat map for a correlation. It should be somewhere there, but we don't have the density plot. These few graphs that would simply transform your data into a vision, into a story. And we are going to learn them. We are going to learn them in the program. Okay, so we are going to apply data visualization, ADA, and statistical analysis. So we are going to apply minimum, maximum, quartiles, and your 25%, 50%, 75%. And all of these 3 techniques here will help us to design a quality book. The code book or quality report is simply a summary of what you have in a summary of how good your data is, how many problems you discover in your data, how many missing values, if any. Do we have any duplicate records? Do we have any outliers? Do we have any typos in there? So we need to transform the raw data into a ready-to-go data set that we could use later. So we are going to use that quality book for the data preparation. So in business understanding, we needed help from the business and domain experts. From data understanding, we needed help from data expert, and this is now. This is no carry on the journey. It's the data science. So I'm going to use the quality book to determine the optimal transformation and conversion methods to use to bring the raw data, to transform the raw data into a new, ready, clean data set. And of course, you could use normalization, factorization, binarization, standardization, etc. So you might not cover all of this, but and this is not an exhausted list of what you should do to prepare your data and bring your data into an acceptable format. So once we have a ready to go version of your data, now it's time to do some modeling. So we are going to select a model based on the analytical approach we determined already at the beginning. It could be a regression model, classification, clustering. It could be anything else. And so once we determine if we are using regression classification, we need to split the data. Splitting the data is one way to learn from the historical data. It's called validation. Also it's called train, test, split. And it's also called, there are other methods, k-fold cross-validation is one of them. Leave one out cross-validation is another. And once you split some of the models, they really require all your features to be on the same scale. That is called, so we need to scale the features, and we are going to learn that process. And of course, we want to build a model, and we want to compare the model to what? We need to compare the model to, if we were to guess, if let's say Amin calls in now with an incident. If I were to guess if Amin is incident is legitimate or fraudulent, probably 50-50, right? So that is guessing. So I want to build a model that is way above 50-50. So I want to build a model that could tell me 90% Amin is liar, 90% Amin is telling the truth. Otherwise, if we were to guess, it's going to be 50%, 50%. And if we were to guess, we don't need you as data scientists. So we hired you because we want you to beat the dummy model or the random model. And we need to build a model. Once we initiated the model, we are going to fit the model on 80%. And we split here in 80%, 20%. So we are going to fit the model in 80%, and we are going to test the model on 20%, and we are going to compare the actual target variable with the predicted target variable. And this is where we come with an accuracy. So we're looking for something better than 50%. It could be 80%, it could be 90%. And once we have, and we are going to build many models, but we are going to pick only one with the highest accuracy. And that one model, there is always a room for optimization, for improvement. And we are going to determine the optimal parameters. And once we have a model with the best model, with the best parameters, now it's time to deploy it into production. And we are expecting a good return of investment. And this return of investment is connected with defined business measurement. Okay, That is the our day-to-day activity as data scientists, and this is probably what we are going to learn from the program. Of course, we are not going to learn everything, but we are going to simply because this is a free mini program, we are going to learn just few things from each area.
Brother Mo, I have a question, please.
Yeah, yes, yes, sir.
So okay, so you said we will come up with like different models, like let's say 3 models, and we will just pick one based on the best accuracy, which one provides the best accuracy. So to define the best accuracy, we need to have like something to scale it with, like a calculator or something, like a something to. This is I'm trying to like understand.
Baseline.
Yeah. Something to tell, like how do I know that this has a better accuracy than this one?
So yeah, we are going to compare for model A. We are going to compare its prediction with the reality, and we are going to have a number 70%. Then model B, compare its prediction with the reality, we got 80%. Model C got 92, etc. That is how we compare. So we are going to compare, and this is a future topic. You might be confused at this point of time. That's fine, but yeah, there is a way to measure the accuracies of the model, and all models, they have to beat the dummy model, which in our case is 50-50.
Okay, and one last question for the auditing. So you said like, let's say I do a model, and let's say, so at the beginning you gave an example. You said like, let's say the next day there are like 5 new cases, and like today I see all zeros, like no fraud, but the next day I do an audit and I find like 111. So like all of them have done fraud. Like, how do I find out that, like how that audit is done? How do I find out that those cases were fraudulent, you know?
So in your historical data, if you don't have a fraud, if you don't have any fraud case, then you are not going to learn anything. Okay, and as a matter of fact, when we started with the business problem, we know that we have fraudulent cases. We know it because the business problem says, in spite of having a fraud investigation team that investigates up to 30% of all claims, we are still losing too much money due to fraudulent claims. So we know that some of the claims were incorrectly approved. So we need, first of all, to identify these cases out of the historical data. So
Is there
say again?
Is there any specific feature that they're looking for in the data set that suggests that this might be the fraud case? Is that how you typically go finding those information?
Yeah, for this auto insurance, you have to have, this is a specific, this is fraud. You have to have an investigation. So number one, find out how much money we lost. So we lost 1 million. Let's say that we lost 1 million last year. 1 million last year. So we need to go to each case one at a time and determine which one that was fraudulent. So we need to. So now, before we have a small data set like this, all what we have is case number, claim number, case number, policy number, client number, his age, information number, and how much, when did they have the accident, and what time, where, what car involved, how many cars involved, if there is any policy, is there any police report, etc. And all of them, we don't have any label. We don't know which one is actually part of this 1 million loss. So now we are going to go through that 1 million loss. It could be manually, it could be systematically, and we are going to create another column here manually or systematically to label each case at a time. So this one is a legitimate 0. This one actually was part of the 1 million, give it a 1. Then 0, 0, 1. Of course, you are going to get probably 80% of all the claims they are zeros, and 20% probably they are 1. So this is one way to audit your historical data and find the claims that were actually incorrectly approved. So we need to determine where is this 1 million coming from, which claims that were incorrectly approved.
Is that the data exploratory exercise that we go through during our data?
Prior, it's prior starting a project.
Oh,
it has to have.
There might be already a data set, meaning.
Yeah, I mean, if you have already a data set with the label, that would be great. But that is the best. The worst case scenario, you have unlabeled data. You have historical data. We lost 1 million, but we don't know which cases were part of that 1 million loss. So we need to identify them first. And now we are going to create a class of fraudulent of claims that were not part of 1 million loss, and we need to create a class or a label or classify the claims that were part of the 1 million loss. So now we have a new column. It's called label or a class or a target variable.
This might be interesting to relate to the classification problem, but how do you know is that something on the description of the problem that it might be a classification versus regression problem?
So again, it depends on how you framed your problem. Depends on how you framed your problem. Let's say that you decided to investigate claims. Okay, you could if you say let's investigate claims and let's find out how much a claim contributes to the fraud. How much? Now we are determining a value. Then we are going to do a regression. If you say, let's find out if a claim is A or B, is a fraudulent or legitimate. That is classification. You classify it as either A or B. And we are going to learn this. We are going to learn this type of learning, machine learning later. So based on how you framed your problem, and based of the objectives you are trying to accomplish, and based on the data dictionary, you could determine if you are going to be doing classification or regression or something else.
One more question related to that: the labeling part that you mentioned. Are you going to classify that as a supervised type of learning, or is it?
Don't talk about this at this point of time.
Okay, sounds good.
Yeah, just leave. Just that is a topic we are going to talk about in the future. But do you understand the concept how you label your historical data prior starting on a project?
So, brother, in this example, the 1 million.
Please hold on.
Okay.
Brother, ask the question about this. Do you understand the concept of labeling your historical data? Mir, I think it was Mir.
Yeah, I understood. Thank you very much.
Good. Okay, what is your question, sir?
Yeah, so I have two parts of the question. So the first part of it is in this example, the 1 million is going to be only the sum of the ones, right? Of the fraudulent cases.
Yes.
Oh, okay.
That is a loss. So we lost 1 million last year. Means we need to find out which cases were part of the loss. And those cases that were part of the loss, we are going to label them as fraud, as F.
Right. So since that already came in the problem as a loss, and which represents the ones, which mean that those ones are already predefined in the data. So they have already done the audit and they already know which ones are fraudulent. And for us, we're going to be base our judgment and doing our models based on those decisions. I mean, based on those fraudulent cases that are already predefined, right?
Yes. So once you if they identified the fraudulent, and we are going to label them as F, and those who are not fraudulent, we are going to label them as L. And now we are going to use machine learning. Let me explain that one more time, and I'm going to let you guys go. Okay, so let's assume that we have a data set that looks like this. Yeah, we got a small data set that looks like this. Okay, and here we got, let's say, age, marital status, gender, income, let's say, no, smoking habit, for example, drinking habit. So we got some values in there, and this is all your 6 million records. Okay, so far so good, everybody. I mean, Mir, are we good?
Yes,
and here
yes.
we got, so as I said, there was an audit, and they audited these cases as either. So we lost 1 million. We lost 1 million last year, and we find out. So this is let's say client 1, client 2, client 3, client 4, client 5, and client N out of 6 million clients, or 6 million claims. So we find out this animal here was actually part of the 1 million. So we are gonna label it as 1. This one was not. This one was part of the 1 million, and this one was part of the 1 million. So now we got a data with features, and we designed our target variable based on auditing. So this is called the target variable. Okay, and now let's say that Amin, no, let's say that Amin calls in. This is Amin, and he's let's say 25, is married, he's a male, he's making 170,000 per annum, he does not smoke, and he does not drink. This is new. This is today. This is yesterday. So we are going to build a machine learning. We are going to build a machine learning that would determine the relationship. So we are going to determine a function. So we are going to use a machine learning to determine a function that maps the features with the target variable. So the function is going to be like this: y, which is target variable, equal a mathematical function of age plus marital status plus gender plus our x's. So we are going to learn this function here. Okay, once we learn the function, we don't know how good the function is. So we are going to learn this function on 80% of your data. And we are going to test that function on 20% of our data. And if the accuracy of the test is good, then now we are going to try that on Amin. And Amin, we don't know anything about him. We don't know anything about his claim, if it's fraudulent or legitimate. So once we learn the function, using machine learning function of relationship between all the combination of all x is features and target variable. We are going to test it on 20%. Then we are now ready. If we are good, now we are ready to predict. I mean, the moment Amin calls in, we are going to apply this function, and it will tell you, hey, it's 1. Then we got to stop it right away before we invest money wise. We are going to stop you. We are not going to pay you anything. If you don't pay you anything, now we are saving money for the business. That is the way it works, and we are going to learn this towards the end of the program. Okay, Amin?
Yeah, thanks, Mo. Thank you.
Okay, folks, that's it for today. I know it's 10 minutes. Let's stay for another 5 minutes, please, to see if you have any question, any concern. And
Mohammed, again, one more question. So these are good answers, definitely. That if we have data, how we are going to proceed and all these things. But the other way around is we talk about 6 million data and how we are going to do different actions. Now, what if we, instead of 6 million, we only have 600 records? Will there be a different strategy that we need to follow, or we will follow everything in the
same strategy if you have 5 records or 500 million records? But the more records you have, the better, the more accurate the pattern, the more accurate the statement, the function you are going to learn. Okay?
All right.
Hi, Brother Mo.
Yes.
Do we have a predefined model? Like, because in every industry we have a predefined model. We do tune that model to get the prediction and the future like values according to the historical data. Yeah, sure. I was asking for the model, to design a model.
I heard your question. Your question is, do we have any predefined model? You could have a predefined model, but that is a wrong decision to take. Why is that? Because all models are wrong. All models are wrong, and some of them are useful. All models are wrong, and some of them are useful. So you could design a great model for a specific problem that works just fine, but when you try to use that model on a different data, a different scenario, it fails. So models, they are not always successful with different scenarios. And by the way, the models, they are not used to fix a problem. They are simply used to help us make a decision on how to fix a problem. So if the model will tell me that Amin is lying, it did not fix the problem, but simply it gives me information, enough information to make a decision on Amin's case. So you could have a predefined model, but it will not work. It might not work from the theoretically, from the conceptual standpoint. It might not work for different scenario, different data, different assumptions. So you have to train your models on the data given to you. Okay, Ali?
Yeah, my question was, if we have some predefined models, so maybe it is good to learn also to get expertise on to define a customized model. Like if we have some predefined models, if you can reference us so we can look at that model, how it works, so then it will also give us some idea when we define a customized model to compare it also.
Yeah, you could do that. What I'm saying, yes, you could do that. But what I'm saying is, if you got a model, if you predefined model that works better, not great for a previous case, that does not mean it is going to work the same for a second case. You could use it. You could use it as a benchmark where you can simply compare, but don't rely on it because it did a good job in a previous case.
Yeah, just for learning. I'm just asking for learning.
Yes, that would be a good practice. That would be.
Yeah, thank you.
You're welcome.
Thank you.
Okay, folks, that's it for today. I really hope that you guys learned something. I'll see you guys next weekend. Until then,
Mo, you have a minute?
yes, sir.
Yeah, so I wanted to ask a question. Is there any possibility we develop a model which is which works perfectly within our set parameters for the given data?
Yeah,
But
that unique.
it might fail. It might fail for the new data. We end up seeing the new problem. We're still processing the wrong claim. Would there be any possibility, such possibility?
Yes, you could design your own model from scratch, but you are going to need someone with PhD in math, someone with PhD in statistics. We have someone with great experience in Python. All of them you can and we need an expert in domain expert, and you could design your own model from scratch. But why do you have to invent the wheel? We already have a dozen of models we can use.
Okay, thank you.
Yeah, welcome.
Hey Mo, one more question. So this is 20-week course, right? This is a mini course. So will we be able to pass the certification test after taking this course, or do we have to take the 30 weeks course in order to?
It really depends. I mean, this program, as I said, is not going to take you anywhere unless you are very super smart. You are very fast in learning. I'm a very slow person. This program is not going to take you anywhere, and it's all what it does is simply guide you through the importance of learning data science. That's it. Why data science, understand the puzzles of data science, how to put the puzzles together to come up with a story, with an image. You don't have to take our 30-week program. That is, I'm not advising you guys, or I'm not marketing for that, but you really need to start your own journey. Learn online, learn on your own. Talk to me. I will provide you all the information you need. But if you decide to take our program, definitely the program is designed is a complete solution.
And this 30 hours program will start in August, right? You said it will start in August.
It's not 30 hours. It's 30 weeks.
Sorry, it's 30 weeks. Sorry, 30 weeks. Yeah, it will start.
Yeah, the beauty about this program is repeatable. The program is a combination of 3 masters and almost 10 years of experience. So there is no way you can complete the program on time. That's why the business offers you the possibility of repeating and repeating and repeating until you land the job of your dream.
Okay, great.
Hey, let me come in really quick. Can you hear me?
Yes.
I forget who was speaking, but I think you said 20 weeks. It's 20 sessions.
Yes.
It's 10 weeks, 2 sessions a week. Okay.
Right.
So it's 20 sessions, or, but physical time, it's 10 weeks. Okay. Now, this is a quick survey course. So you cover a little bit about everything, but you don't even cover everything. So like we said, you cannot cover everything, especially in this ridiculously short period of time. So keep learning. The other thing is the 30-week program. It's crazy serious. It's 30 weeks, but 5 sessions per week. So it's a huge investment in time, folks.
3 hours per session.
Yeah. And you got to do homework on top of that.
Yeah,
so in our free programs, we're a little relaxed.
Yes.
Okay, got it. Okay, now makes sense. Okay.
That is roughly between 15 to 20 hours a week. But I promise, I'm going to get the job. You are going to get to where you want to be to work in the program. As a matter of fact, I have 3 students. One of them, and from last batch, one of them is working now with Amazon for $220,000 per annum. Now, when I heard the story, I was about to cry. Now, I was so happy that one of my students got there. Okay. So, guys, you really don't need to take the program. Now, there's a lot of ways to do it. But if you decide to take our program, of course, we are going to treat you as our own family. We are going to definitely invest in you. We want to make sure that you excel, you graduated with knowledge, experience needed, and at the end, we are going to help you with resume preparation, interview preparation, and job placement. In data science, the only discipline that I don't want anyone to market you, I don't want anyone to get you a job is data science. So I could get you a job for $100 per hour, and I'll give it to you for $60. So you're going to be my donkey for probably 2 years, making $40 on. So data science is in high demand. Once you know, you feel like you are ready, you market yourself, and we are going to help you with that. I got a lot of emails, a lot of calls from some of the companies here in US. They are offering a job for $35. And in one of the emails, I was so upset. I was so mad. They have my resume. They saw all my experience, and they are offering me a job for 35. I told them this is a highway robbery. Shame on you. And they never responded back. So there are a lot of people there out there. They are going to use you. They are going to use you. So the only discipline that you really should market yourself easily, and we are going to support you, is data science, because there are a lot of high demands. You are going to get a job like this if you know how to sell yourself. Okay, that's it for today, guys, and I'll talk to you next week. And until then, you guys have a great weekend, and bye, everybody. Assalamu alaikum wa rahmatullah.
Walaikum assalam. Thank you very much.
Walaikum assalam. Thank you.